having described the service model, so the transit relationship and the peer relationship, we are now in the position to try to build a more generic understanding of the large-scale structure of the internet. What we mean by large scale, this means that the individual entities that will show up in this model will not be individual hosts or routers, but rather ASs, and we are just going to ask which way ASs just connect into one to each other's network, and which sort of relationships we can see in this large-scale structure of the internet. And to build this understanding, we are going to just use this simple service model that we introduced so far. So one very important aspect that is might be overlooked, and we haven't really discussed this far, is that it can very well happen that the customer that buys transit service from provider also resells the transit service to other customer ASs and so on. So there can be actually a chain of transit relationships that connects a customer to an individual, to a direct provider, but then the provider can also buy transit service from an upstream provider, and this can go all the way up to a certain point where we have the case that we arrive to an AS which in itself does not have any more upstream ASs, so it has no providers. Now this brings us to our first definition. Any AS by definition which does not have an upstream AS in itself, but somehow manages to provide connectivity to the rest of the internet without actually using the services of a transit provider, this will be called a tier 1 autonomous system. Okay, so the first definition is that any AS with no upstream AS, this is a tier 1. A little bit of thinking will bring us to the understanding that whenever we talk about an AS without an upstream, that particular AS must be global. So it must possess and operate a network infrastructure that can connect any two ASs throughout the world, regardless of the geographic distance between these two ASs. Because if this would not be if this was not the case, then of course our AS would need to use the service of a transport AS, but then by definition it would no longer be a tier 1. So tier 1s are usually global internet service providers that have their own global network infrastructure, and they can provide connectivity between any two ASs throughout the internet. A second little thought, that we are not going to go into details just right now, will make it possible for us to convince ourselves that tier 1 ASs must form a full peer mesh between each other. So at the highest layer of the internet, there is a full mesh network of peer relationships, bilateral peer relationships between any two tier 1 ASs in the internet, because that's the only way to have global reachability in this particular structure. As of 2019, there were 15 tier 1 ASs throughout the internet. There are of course the large US based service providers like AT&T and CenturyLink, but of course there are lots of European actors here like Orange, Deutsche Telekom, and Telecom Italia. We also have tier 1s from India, from China, etc., etc. This is NTT, the Japanese telecommunication provider. And again, tier 1s actually lie at the highest layer or the highest level in the transit hierarchy, because they are not confined to use the transit service of any other ASs. They can handle connectivity at their own level. Tier 2 AS is any direct customer of a tier 1 AS, which is often a global network on its own right. A regional provider is usually, or this is also called tier 3, This is a provider that provides internet access throughout some geographic region, like Comcast in USA or Orange in Europe. But of course, Orange is also tier 1, so this also somehow anticipates that this distinction will not be too exact, and there are a couple of loose edges or corner cases that are not correctly classified by this tier-based separation. Regional providers typically provide transit service to national providers. So national providers are tier 4. These are country-wide internet service provisioning enterprises. And at the bottom of the transit hierarchy, we have single and multi-home customers and stub ASs. So this is basically the internet edge. This brings us to what we call the transit hierarchy of the internet. Again, at the highest layer, we have tier 1s. Again, a tier 1 is such that it does not have any transit link at all. They must have a peer full mesh between one another, and any two ASs connected to the internet are in some way or another also connected through these tier 1s, even though it might not be immediately important to actually use this connectivity to exchange traffic, because there can be shortcuts. These are usually provided by peers. So tier 1 is global, tier 2 is either global or regional, tier 3 is regional, tier 4 is national service provision, and tier 5 in this simple transit hierarchy are the internet edge. Unfortunately, so this is a very nice and elegant and clean model. Problem is that this is just an approximation of what's going on in the reality. So this is a nice model for us to actually try to build a mental model of the large-scale structure of the internet, and to some extent this might even be the case, what we find out there, but the reality is much more messy than that, and unfortunately there is not enough proof out there in the internet. There is not enough data to actually characterize to what extent this model describes reality, and to what extent the transit hierarchy is still the case that's going on in the internet. The internet is unfortunately terra incognita. So the first important thing, it is in unknown territory. First of all, the transit peer taxonomy. So these two very simple models of AS-AS business relationships, the transit and the peer relationship. This basically just covers about 70% of the real AS-AS business relationships. So there was a large-scale survey that showed that there are lots of ISPs and lots of ASs that diverge from this simple model. Two typical examples that also come up in this context is paid peering, which is basically peering relationship, but one ISP pays a fee to the other. This is usually asymmetric peering relationships. A sibling AS is a mutual transit between two ASs. This is usually the type of relationship that exists between two ASs that are operated by a single administrative entity. And there are, of course, lots of unclassified policies. We don't know the policies. Most of the time, ASs do not publish their business relationship, because this is well-held business secret, and therefore there are lots of possible types of business relationships between ASs that we do not even know about. Business relationships are a secret, because knowing an AS's business strategy is a competitive advantage for other ASs. So this is a well-held business secret. Still, there are a couple of ASs which publish their business relationships in a distributed database that is called the Internet Routing Registry. And again, the Internet Monitoring Lab will have the opportunity to look into the IRR and identify the peering policy and the business relationships of a couple of ASs. We can also do measurements, usually trace route measurements, which will infer, which can use to infer business relationships, but this is of course much less reliable than direct reporting. The second problem, it's not just that we don't know the business relationships, we don't even know whether there is a physical link between two ASs or not. So even the highest level topology is something which we do not know. The tier classification itself is only just a guess. We've seen many examples when tier 1s actually directly provide services to national ISPs. We see examples when an actual AS is both a tier 1 and the regional provider. There are all sorts of different peering links which go not just between different levels, same level of the transit hierarchy, but span multiple levels, etc., etc. So this is only just a mental model for ourselves to get a big picture understanding, but the reality, in fact, is much more messy than that. And of course, there are lots of cases when tier 1s also terminate peering, so it might not be very well the case that at a certain moment in time there is no peer full mesh between tier 1s. This is called the peering act, and whenever a peering war like this comes up, you can be sure that this will be a leading news item in the related portals reporting. What we are seeing more and more out there in the internet is that this transit hierarchy that usually maybe 10 or 20 years ago very nicely described the structure in the internet starts to flatten, which basically means there are lots of peering relationships that are being created thanks to the mass effect that is created and that is actually just involved by IXPs, and we are seeing an evolutionary process when the internet slowly transitions from this nice initial strict transit AS hierarchy into a fully decentralized peer full mesh. Now, at which point we are in this transition is not something which we know very closely, but rest assured that this is a process that is going on in the reality. But again, these peering relationships are mostly not known to us. It's not just the case that the ES level hierarchy is not known. We don't even know the ES topology of the internet. So everything that we just said this far, the service model, this is just an approximate view of the large-scale structure of the internet. But within this particular limitations, this is already quite a capable model, a very simple and a very interesting and a very descriptive model of what's going on in the internet. So basically the rest of the lecture series will be about applying this service model, transit and peer hierarchies to the routing ecosystem and actually configuring these types of business relationships and routing policies into actual BGP routers. But this is on for the next occasions.